Everyone, this is a OCR exam board, one of the latest Core 1 exam papers that I'm going to solve through this in this video. I will go through the details in each question, and this would be a good revision for a whole Core 1 if you are looking at doing an exam for Core 1 this year. The exam paper itself and even mark scheme, they can be downloaded from MathRaven website, as you can see down in this address on this page. So I'm going to start with going to the next page and looking at our first question. First question, simplify bracket 2x minus 3 squared minus 2 times 3 minus x squared. So we just need to expand this and simplify. The main problem students they have with this sort of questions is that sometimes they write, for example, 2x minus 3 squared, they write it like 4x squared, for example, minus 9 or something like that. So they just square this element and that element, which is not a right approach. So I'm just going to return back to the basically the just a question, and what you need to do is you need to just time it as a normal time. So when we say squared is a term times itself. So 2x minus 3 times 2x minus 3 minus 2 times 3 minus x, again times 3 minus x. So we're just going to do a expansion in here. So this is almost similar to what you had in GCSE. So you need to time all of the terms together and time it and add or minus each other. So 2x times 2x would be 4x squared. 2x times minus 3 would be minus 6x. Minus 3 times 2x would be again minus 6x. Minus 3 times minus 3 would be plus 9. Then this side, I am going to, as I am expanding in this section, I'm going to also time it to 2. 3 times 3 is 9 times minus 2 in here. So I'm just going to consider that minus. 3 times 3 is 9 times minus 2 would be minus 18. 3 times minus x is minus 3x times minus 2 would be plus 6x. Then minus x times 3 is minus 3x again, times minus 2 would be again plus 6x. Minus x times minus x is plus x, times minus 2x would be minus 2. So minus x times minus x would be plus x squared, times minus x would be minus 2x squared. So now I need to simplify this, and I need to simplify the x2s with x2s. So 4x squared minus 2x squared would be 2x squared. 6x plus 6x would be 12x. Minus 6x would be basically 0. They all basically eliminate each other, 6x and minus 6x. 9 minus 18 is minus 9. And we don't have any other number, so the final number in answer in here would be 2x squared minus 9. Now going to the second part of this question. Now going to the second part of this question, find the coefficient of x cubed in the expansion of 3x squared minus 3x plus 4 times minus 5 minus 2x minus x cubed. So we want to look at finding the coefficient of x cubed. I'm just going to write that in here so that we see it better. 3x squared minus 3x plus 4 times 5 minus 2x minus x cubed. So if I'm looking for just a coefficient of x cubed. So, but still I know that if I expand this, I need to time each one of them to the next, all of the terms in the next one. So in total I have 9 timing to do, but I don't need to do all of them because I'm just only looking for the ones that they give me x cubed. So 3x squared times 5, it is definitely not x cubed, it's x squared. So but 3x squared times minus 2x, that would give me x cubed. So I'm just going to write them in here. So this would be minus 6x cubed. 3x squared times x cubed, again, would not give me x cubed. So the other one is this one here. Now I'm coming to this minus 3x. Minus 3x times 5, it would not be x cubed. Times 2x would be x squared, which is not x cubed. Times x cubed would be x to the power of 4, which is again not x cubed. Then I have on a 4 times 5 would not have any x cubed. 4 times 2x, again, no x cubed there. And 4 times minus x cubed would be x cubed, which would be minus 4x cubed. So I need to add these together. So my just the x cubed term would be minus 10x cubed. So if the answer, find the coefficient of x cubed in the expansion of this, the coefficient of x cubed in that expansion would be just minus 10. Question 2. Express this fraction in form of a plus b square root of 5. So as we can see, this is in chapter 1 of core 1, this is a rationalization to eliminate surds from the denominator. So with these cases, we would be timing both numerator and denominator to a term that is 1, but in the denominator would create a difference of 2 square. So that is 3 minus square root of 5. In fact, we are timing that to 1 because 3 minus square root of 5 divided by 3 minus square root of 5 is 1. So why we do this? Because now by timing that, this would be equal to this, now this 2, when we time this to that, this is a difference of 2 squared. So that would be 3 squared minus square root of 5 squared. And the top part, in the numerator part, I just need to time it again. So 3 times 3 would be 9. 3 times minus the square root of 5, so minus 3 square root of 5, plus 3 square root of 20, and square root of 20 times minus the square root of 5, that would be minus the square root of 100, which is, I'm going to write it for now, minus the square root of 100, because the square root of 20 times the square root of 5 is the square root of 20 times 5, which is the square root of 100. So if I simplify this a bit further, of what I have at the top, square root of 100 is 10. So I will have 9 minus 10. And what about this square root of 20? How can I can simplify that? Square root of 20 equals square root of 4 times square root of 5, which is equal to square root of 5. So if I simplify a bit further, I will have 9 minus 3 square root of 5, 3 times 2 square root of 5, because this is, I have found that separately, would be plus 6 square root of 5 minus 10 divided by 9 minus 5. So if I again simplify a bit further, so it would be 3 square root of 5 minus 1 divided by 4. So if I now, if you like, separate these terms in this fraction, this would be 3 square root of 5 divided by 4 minus 1 over 4. So if I look at my case in here and compare the answer that I have in here with this one in here, my A is equal 3 over 4, or you can write 0.75 if you want to, and B equals 1 over 4, which is 0.25. Okay, so just again, do remember as a revision in here, if you have something like, for example, 1 over square root of 2, and we want to rationalize, we time it to square root of 2 divided by square root of 2. So we time it to the denominator itself. But when in denominator we have two terms, we have to time it to a term that would make a difference of 2 squares. So if this is plus in here, this has to be minus. If that was minus, this has to be plus to make that difference of 2 squares. I'm just going to again write this difference of 2 squares. A minus b times a plus b is equal to a squared minus b squared. As a revision, if you want to look at this one, how that timing works there. Question 3, solve the simultaneous equation x squared plus y squared equals 34, 3x minus y plus 4 equals 0. We have a circle in here. The circle is centered in the basically in the origin, and the radius of the circle is square root of 34. So we have a circle like this, which is in the origin, and then we have a line in the other side. So that when we say solve simultaneous equations, that basically means that depending on the circumstances, we could have no answer, maybe one answer, or we could have two answers, depending on if this line is intersecting that circle in 1 point or 2 points or no points. But how we establish that with these questions, when we have a quadratic plus a linear to solve a simultaneous, the best method is a substitution. So substitution is we find x or y from normally from this linear equation, and we replace it into that quadratic equation. So from here, if I take the minus y to the other side, it becomes plus y, so y would be equal to 3x plus 4. Now I'm going to replace this y in here and write it in here. So x squared plus 3x plus 4 squared equals 34. I need to expand and make it in a standard form of quadratic equations. So this would be x squared plus 9x squared plus, if we time it, again, expand it, 3x plus 4 times 3x plus 4. If you do that, you will find this would be 24x plus 16 equals 34. To make it a standard form, I just bring everything to the left and simplify this. So this would be 10x squared plus 24x minus 18. Minus 18 equals to 0. This can be just slightly simplified. All of the numbers are divisible by 2, so this could be 5x squared plus 12x minus 9 equals 0. This simplification just makes the numbers a bit smaller, easier to calculate. So we just need to put it on a formula for quadratic equation, minus b plus minus square root of b squared minus 4ac, all divided by 2a. So I'm going to replace it in here. So this would be minus 12 plus minus square root of b squared would be 12 squared would be 144. Now minus 4ac. So I'm going to do minus 4 times a, which is 5, and times c, which is minus 9, divided by 2a, which is 10. 5 times minus 9 is minus 45, times minus 4 is plus 180, plus 180 and 144. That would be 324 under the square root. Square root of 324 is 18. So this would be minus 12 plus minus 18 divided by 10. So the answers that you get from here, minus 12 minus 18 is minus 30, divided by 10 is minus 3. and minus 12 plus 18 is 6, divided by 10 is 3 over 5. We can write it in that form, or if you wanted to put in digital decimal format, we can put this would be 0.6. So considering that we have two answers, we see that the line that we have, it is intersecting the circle in 2 points, because we have two answers in here, 2 points for two answers for x. But how we can find the points? We know the x values. If we replace them into this one in here, we can find the y values. So if x is minus 3, y would be equal to minus 3 times 3 is minus 9, plus 4 is minus 5. And if x is 3 over 5, then times, I'm again replacing in here, y would be equal to 3 times 3 over 5, which would be 9 over 5, plus 4. 4 itself is 20 over 5, so this would be 29 over 5. So the answers for intersection, or if you like solving the simultaneous equation, would be minus 3 and minus 5, and 3 over 5 and 29 over 5. Again, the reason that this the answer for the simultaneous equation is the intersection is that when we say intersection, the points of intersection, they are x and y's, that they have to satisfy this equation for the circle because the point is on the circle, and also they have to satisfy the equation for line because the point again is on the line. So in a way, that is definition of simultaneous equation. We want to find x and y's that those x and y's satisfy both of these equations, and that is exactly the definition of intersection. So this one, this question says solve the equation 2 y to power of half minus 7 y to power of 1 over 4 plus 3 equals 0. The point in here, what we really need to look at in here is that y to power of 1 over 4 all to power of 2 equals y to power of half, because that would be equal to y to power of 2 over 4. 2 over 4 is 1 over 2. So if I come in here and make a variable and call that variable x, I can call it anything, but I'm just going to call it x because we are used to it, and call this x equals y to power of half. I'm just going to, rather than half, I'm going to call this x y to power of 1 over 4. If I have this, and if I rewrite that based on this assumption, what I get is that 2x squared minus 7x plus 3 equals to 0, based on that assumption. Again, I can use a direct formula to find out x from here. As you can see, in the direct formula for quadratic equation is very important in Core 1. You need to be able to use it and use it efficiently and on time. So minus b would be 7 plus minus b squared would be 49 minus 4ac minus 4 times 2 times 3. 2 times 3 is 6 times 4 is 24, so this would be 24, and divided by 2a would be 4. So this would be 7 plus minus 49 minus 25 is 24 is 25, square root of 25 is 5, divided by 4. So the answers in here is 7 divided plus 5 is 12, divided by 3 is 3, divided by 4 is 3. 7 minus 5 is 2, divided by 4 is 1 over 2. Now that we find the value for x in this equation, we come back and we replace it in this assumption that we made we replace the y to power of 1 over 4 equal x. So this basically means that y to power of 1 over 4 could be equal to half, or y to power of 1 over 4 could be equal to 3. Okay, now if I from here, if I time everything to so if I power both sides to 4, so what that basically means is that power that and power that to 4. If we do that, on the left hand side we will have y equals, on the right hand side 1 over 2 to the power of 4 would be 1 over 16. So y would be equal to 1 over 16. Okay, and if we look at this one in here, again, if we do the same thing, both sides to the power of 4, left hand side would be y, the right hand side would be 3 to the power of 4, which is 81. So our answer for y could be basically 1 over 16 or 81. So we have two different answers. Okay, if you go to the next question, express the following in the form of 2 to the power of p. So this is indices. Indices, you have learned these in the GCSE Maths, and again, this is more emphasized and a bit expanded in Core 1. So it is a fundamental to learn the Core 1, and especially these cases to progress to better to the next Core 2, 3, and 4. So if you look at this 2 to the power of p, if I look at this, the first one, 2 to the power of 5 divided by 2 to the power of 7, that would be 2 to the power of 5 minus 7. That is the indices. All to the power of 3. I'm just keeping that to the power of 3 there. So 2 to the power of minus 2 to the power of 3. And 2 to the power of minus 6, all of this using the indices equations. And you can, for this, you can write, I think that is the end of this question, so you can keep it as 2 to the power of minus 6. But if you ever wanted to make it into a fraction, you could write 1 over 2 to the power of 6 or 1 over 64. But for this question, we can just keep it in that form because that is what we want to achieve. The second question, we have 5 times. Now, because it's what we want to achieve is 2 to the power of p, I need to try to write everything in a form of 2 to power rather than 4 to power. If you see, this one is a 4 to power of 2 over 3. So to do that, I know that the 4 itself is 2 to power of 2. So that is 4, and I write the rest of it, which is 2 over 3, plus 3 times. Now, this one, 16 to the power of 1 over 3. Again, for 16, I can write 2 to the power of 4. I need to write, if you like, convert this 4 and 16 to 2 to power so that I can achieve the form that we are looking for. So I'm just writing 2 to the power of 4, all of that to the power of 1 over 3. So this would be 5 times. This is again an indices rule. It would be 5 times 2 to the power of 4 over 3 plus, this would be plus, again 3 times 2 to the power of 3 times 2 to the power of 4 over 3. So 5 times 2 to the power of 4 over 3 plus 3 times 2 to the power of 4 over 3. If we can basically make that 2 to the power of 4 over 3, we can factorize that. So that would be basically 5 plus 3, which basically is 8 times 2 to the power of 4 over 3. But 8 itself is 2 to the power of 3 times 2 to the power of 4 over 3. And this would be 2 to the power of 3 plus 4 over 3. Is that right? Because this is again indices, we need to add them together. So this would be 2 to the power of 3 plus 4 over 3. 3 itself is 9 over 3, so this would be 13 over 3. 2 to the power of 13 over 3. So our P for the second part is 13 over 3. Question 6. Express 4 plus 12x minus 2x squared in the form of a times x plus b squared plus c. So this is basically foundation to that use of completing the square, and this is how we sort of use this sort of format to complete the square. So if I just start from this, but I'm just going to write with the normal standard form, minus 2x squared plus 12x plus 4. So that is same as this. For this, when we want to write completing the square, we just need to have this x squared. We want that to have a coefficient of or just time to 1 rather than minus 2. So I can do a minus 2 and factorize everything with minus 2. So this would be x squared, that is what we want. And this would be minus 6x, and this would be minus 2. These are minus because we are factorizing minus 2. So if you see, the pluses becomes minus. Now that we are in here, I can again write in here minus 2, and I need to keep that organization going. I need to keep the terms as it is, as when I'm putting equal. So when I am looking at completing the square, which is using basically this a minus b squared equals a squared plus 2ab plus b squared. So if I compare this to this in here, my a is x. So my a is x, so this is also a. So if I compare this, minus 6 would be equal to 2b. Or in a way, b would be equal to minus 6 divided by 2, which is minus 3. So just to make it, if you want to remember the coefficient that we see in here, if we divide that by 2, coefficient of x, divide that by 2, we get b squared. So what we need to do, we need to add b squared and take b squared out to make a completing square. Because we know that this would make a completing square. So if we have a squared plus 2ab, we need to add b squared. So this would be x squared minus 6x. Now our b is minus 3, so b squared is 6. I'm going to add plus 9 minus 9, add and take out, and the rest is minus 2. You see, I'm still keeping that organization going. I'm just basically what I'm doing is just adding 9 minus 9 is a 0. But the reason that I'm doing that is because I know that this 3 make a completing square. And that completing square is minus 2. That would be x minus 3 to the power of 2. And the rest is minus 9 minus 2, which is minus 11. Okay, now I can expand this minus 2 back into this bracket. So this would be minus 2 x minus 3 squared, and minus 2 times minus 11 would be plus 22. If I compare this now to the term in here, my a is minus 2, b is minus 3, and my c is 22 plus 22. Now state the coordinates of maximum point of a curve, which is y equal 4 plus 12x minus 2x squared, which is, if you see, this is exactly same as that. So to look at where this what that maximum point of curve means, I'm just going to look at this into have a quick discussion into in a page. So when we have quadratic equations could be either this or in this form, or it could be in either of this formats. So quadratic equation is ax squared plus bx plus c equals 0. And we know that from the formula x is minus b plus minus square root of b squared minus 4ac divided by 2a. So depending, in this case we have a is positive and in this case a is negative. So if a is positive, we will have a minimum point in the curve. If a is negative, we will have a maximum point on the curve. So this is our x and y. But how we can find the coordinate of that point? The point basically in here is any quadratic form is a symmetrical curve. So I can put a symmetrical line in here. So when I put a symmetrical line, it means that this point is in the middle of this point and that point. I can do the same thing in this side. So this point is in the middle of that and that. And we know that these 2 points are solutions of the equation. So these are our x's when we solve the equation, because they are the points that y equals 0. In these 2 points, y equals 0. So if we solve this equals 0, the x's that we find, those are 2 points. And as you can see in here, one of the x's is minus b plus square root of b squared minus 4ac divided by 2a. And the other one is minus b minus square root of b squared minus 4ac divided by 2a. So we have 2 different x's coming from this equation. So if I want to find out x of this point, I will need to add these 2 together and divide, because that is in the middle of those 2 points. So if I add these 2 points and divide by 2, because I want to make an average, this would be minus, if we add, because they're already a common denominator, and this basically simplifies with that, because that's plus, that's minus. So what I will have is minus 2b divided by 2a, and then I need to divide it by 2. If I divide it by 2, it basically means I'm timing by 1 over 2. And if we simplify this, so the answer would be minus b divided by 2a. So this x in here, the x of this minimum, maximum or minimum, so this x is always minus b divided by 2a. So when we find the x, if we know the x, if we put the x into the equation of the curve, we can find what is the y. So we can find what is the y of that point. Okay, that is what we are going to do. So x value is minus b over 2a. So for the second part, for this one, my a is minus 2, my b is minus 12, plus 12. So plus 12 and minus 2. So these are the values that I have. This is my a and this is my b. So x equals minus b divided by 2a, which is that x of that maximum or minimum would be equal to minus b would be minus 12 divided by 2 times a, 2 times minus 2 would be minus 4, which would be equals to 3. So x of that minimum or maximum point is 3. So if I could put this back into this equation here, this equation, put the x equal 3 in there, my y would be equal to 4 plus 36, 12 times 3, minus 2 times 9, 3 squared is 9, 2 times 9 is 18. So this would be 18 plus 4 is 22. So if you like, the maximum or minimum answer, the point in the curve would be 0.3 and 22. But to find out if this is minimum or maximum, as you can see, because our a is negative, our curve is in the form of this. So our curve is in this form. So the point that we find in the other side, which is 3 and 22, that is basically a maximum point for that curve. Okay, so if we look back, state the coordinate of the maximum point of the curve. So this is the maximum point of the curve. Okay, so we go to the next question. Question 7. Sketch the curve y equals x squared times 3 minus x, stating the coordinates of the points of intersection with axis. So we want to sketch this curve and stating the coordinates of the points intersection with the axis. So it would be x and y. So I'm going to start from looking at a point in here. This is our x and this is our y. When I look at y equals x squared times 3 minus x, if I put this equal to 0, what would happen? I would have x equals 0 or x equals 3. So in a way, this curve, the intersecting points for this curve are x equals 0 and x equals 3. So this is the 2 points. Now, the other point that we need to look at in here is that we have, if I expand this, this would be minus x cubed plus 3x squared. So if x is because of this minus x cubed, we should sort of have a starting point and a sort of ending point in here. Because when x is in positive infinite, our y is negative infinite. When x is negative infinite in this side, our y is a positive infinite because of this minus sign in here. Okay, but the other point that we need to look at, x squared in here, x equals 0, could be basically a tangential point, because we have x squared, so we have twice, if you like, x squared equals 0 makes it x twice equals 0, which basically means like we have 2 points that they're approaching to each other to make a tangent. So if I add up all of these things together, we could have something like this. So this is the estimate of this graph. So if this is the estimate of this graph, with points 0 and 0 and 3 and 0 in here, this curve will only intersect the y in just 0 and 0, the same point that it is intersecting x-axis. How about we have a look and make sure that that is the case? So if I have y equals x cubed minus 3x squared, if I put x equals 0, basically, if I put x equals 0, because when we talk about intersection with y is the points that their x is equal to 0. If x equals 0, if we put this in here, our y will be also equal to 0. So that is the only point that we will have the curve intersecting with y-axis, which is consistent with what we analyzed before to do this approximate sketching. Now, going to the second part of the question, the curve y equals x squared times 3 minus x is translated by 2 units in a positive direction parallel to the x. So translated in 2 units to the positive x, so that would be 2 units in this direction. State the equation of the curve after it has been translated. So if you remember, when we have fx, sketched fx, when we have 2 units to the right, that basically means function of x minus 2. Function of x minus 2. So basically, if this is a minus 2, it would the curve would go to the right. If it was a plus 2, that would go to the left. So if our fx, which is in here, we have that is fx equals y, which is equals to x squared times 3 minus x, our f of x minus 2 would be x minus 2 squared, because now we are just replacing x with x minus 2, times 3 minus, again in here, x minus 2. Just look at here, I'm just putting x minus 2 wherever I have x, and I need to be careful about the brackets. So if I look at simplifying this, would be x minus 2 squared times 3 minus x plus 2. So this would be x minus 2 squared times 5 minus x. So this would be 3x minus 2 squared times 5 minus x. Just to check your answer, what we could do, maybe just to check the answer, is we could say that if this moves 2 units to the right, this would be something like this. So this point is 2 and this point is 5. So intersection with x now is 2 and 5. So if we solve this, if we make this equal to 0, what we'll have? We will have x minus 2 equals 0, which is x equals 2, and we will have 5 minus x equals 0, which is x equals 5. So we get the same intersection, which is 2 and 5. So this is our y. Now, if I make x equals 0, then y would be equal to, if I put x equals 0 in here, I will have minus 2 squared, which is 4, times 5, which is 20. So my intersection here would be point 20. And as I said, this is not to scale, but this is to show you that we can check the answer and just make sure that what we have is consistent in all aspects. So our final answer for section part B is basically this one in here. So our function would be x minus 2 squared times 5 minus x. Now part 3 is describe fully a transformation that transforms the curve y equals x squared times 3 minus x to y equals half of x squared times 3 minus x. So what is happening in here? We have fx, which is equal to x squared times 3 minus x. If we look at the second part, which we have half. So in the second part, we have, if you like, half of fx, which is basically half of x squared times 3 minus x. So we are basically timing to half the initial function. So when we say we are timing to half, you see this is our previous y, and which was in here, but this is our new y, which is times half. So what happens if we time everything from a y aspect to half? Just look at what happens in here. I'm working on the green curve. So just to be clear, I'm going to go to the other page and draw this again. So our original function is similar, is something like this. So we're looking at half of f of x, or half of y. So if the y is in here, whatever that is, the y in half, when we time it to half, would be half. So that would be somewhere around here. So that point moves in here. This point has a y of equal to 0. So half of 0 is the 0 itself. Again, this is y equals 0, so half of that would be again 0. But any other point, it would be the y's would be reduced to half. Again, this one in here, the y would reduce to half. This one in here, the y would reduce to half. And the same in here. So the y value in here would reduce to half. So that point will move to this point. So if I connect all of these together, now what we see, so if we do all of the y's divided by 2, basically we are stretching the function. So by doing this, we are stretching the function. So describe Fourier transformation that transforms this to that. That description would be basically this half of f of x, and that is stretching the function along x-axis. So going to the next question. A curve has equation y equals 2x squared. The point A and B lie on the curve and have x coordinate of 5 and 5 plus h, and respectively, where h is larger than 5. Show that gradient of the line AB is 20 plus 2h. So this is a basic definition of gradient. Gradient equals change in y divided by change in x. Now, if we put these 5 and 5 plus h, with the 2 points that we have, one of them is 5, x is 5, we put it there, 5 squared is 25, times 2 is 50. So 5 and 2 are 50. The second one, the x is 5 plus h, 5 plus h, and then we need to put 5 plus h in here to find y. That would be 2 times 5 plus h squared. So I'm going to expand it, or just write it for now, 2 times 5 plus h squared. So these are our x and y. So this is y, this is y, and this is x and this is y for 2 points. So our delta y over delta x would be delta y would be 2 times 5 plus h squared minus 50 divided by 5 plus h minus 5. Okay, now I need to simplify this. So this would be equal to, this 5 minus 5 would be just h. And I expand the top one. So this would be 5 squared with 25 times 2 is 50. Inside that would be 2 times 10h times 2 is plus 2, 20h. So if I'm a bit fast, try to expand this in here and do it with steps. But you need to get, after some while, especially in core 1, you need to get used to these things a bit faster. H squared in here times 2, which would be plus 2h squared minus 50. So minus 50 simplifies with this 50. So I have 2h squared plus 20h divided by h. If I simplify the h from the top, I will have 2h plus 20, which that is equal to this in here. So we did not do anything else apart from just using the basic concept for gradient. Explain how the answer to part I relates to the gradient of the curve at A. How the answer at part I relates to the gradient at part A. So to look at this is what we want to do in here, is that gradient of this function at point A is, we could basically consider if for any curve. So this is a definition of differentiation. So for any curve, if we want to find out a gradient of or tangent to the curve in this point, I can say that I have another point, and if I connect these two together and move this close enough to this point, what I get is the exact gradient of the curve in that one point. In a way, this is over 5 and this is h, so this would be 5 plus h. So if I reduce the h to h equal to 0, what I will have connecting these two lines together, that line would come into this line, which is exact tangent to the curve at point A. So if I put h equals 0, basically what we want to say is that the gradient of the curve at point A equals 2 times 0 plus 20, which is 20. So I'm just putting in here, I'm just replacing the h with 0, and that would be the gradient at point A. So that would be the gradient at point A. The section 3, the normal to the curve at A meets the y-axis at point C. Find the y coordinate of C. So now imagine that we have the point A and we have the normal. Normal means it is vertical to the tangent. So we know that gradient at point A is 20 because gradient is, and that 20 is a basic gradient of tangent to the curve at that point, because we are having a curve, so we have a tangent to the curve. So gradient of the line that is vertical or a normal to the curve at A, that would be the one that's perpendicular to the tangent. So gradient of this, a normal line would be gradient would be minus 1 over 20, because gradient of that is 20. So that would be, and these are perpendicular. If you look at the condition for perpendicular lines, the gradients time each other equal minus 1. So this would be minus reciprocal of the other gradient. Now we are having a gradient of that line which is minus 1 over 20, and we know that point A is, which is this one in here, point A is 0.5 and 50. So if I come and say that in here we want to, if I call this line for example C, if I want to find out what is the equation for line C, if it's a line that passes through 5 and 50, which is point A, and the gradient is minus 1 over 20. So the equation of that line would be y equals minus 1 over 20 x plus c. To find out c, we need to put this 5 and 50 inside this equation to find out what is value of the c. So I'm just going to do it in here. So y would be 50 equals minus 1 over 20 times x, which is 5. So this would be times 5 plus c. So minus 1 over 20 times 5 equals this would be minus 1 over 4. So if I take the minus 1 over 4 to the other side, from here c would be 50 and 1 over 4. So 50 and 1 over 4, or 50.25 if you wanted to write it in a decimal format. And that would be the y coordinate of intersection with y-axis, because C itself is a y-intersect. So this is y-intersect in that line. Okay, so if you go to the next question, find the set of values of k for which the equation x squared plus 2x plus 11 equals k times 2x minus 1 and has two distinct real roots. Okay, this is about discriminant, and if the discriminant of a quadratic equation is larger than 0, is two distinct real root. If it is equal to 0, is one root, and if it is less than 0, it is no root. So I just need to convert this to a standard quadratic equation. I'm going to expand first. X squared plus 2x plus 11 equals 2kx minus k, and then bring everything to the left to make it a standard form. X squared plus, as I am bringing this to the left, I'm also taking the factorizing x, which will be 2 minus 2k, and the rest would be plus 11 plus k equals 0. So if you look at here, this is my c, this is b, and my a is 1. But discriminant is b squared minus 4ac. So that has to be larger than 0 for us to have two distinct real roots. So I'm just going to write that down. So this will be 2 minus 2k squared minus 4ac. So this would be 4 times a is 1 times 11 plus k. And this has to be larger than 0. So again, I am going to expand this in here. So this would be 4 minus 8k plus 4k squared minus 44 minus 4k. It is larger than 0. Minus 44 minus 4k larger than 0. And I'm going to simplify. So I have 4k squared. Now minus 8k minus 4k minus 12k. 4k minus 44 would be minus 40. That needs to be larger than 0. All of this divisible by 4, we can just divide by 4 to simplify it a bit. So k squared minus 3k minus 10 should be larger than 0. This is a good question because it evaluates your understanding of discriminant and the solution for a quadratic equation. In the same time, at the end, as you can see, it results to a inequality in a form of quadratic equation that needs to be resolved to find out what should be the k. So how we can solve that? First of all, I can find the solutions of for k squared minus 3k minus 10 equal to 0. If I do that, and then we discuss how we can find the solution. So solution for that, if I just use the formula in here, or I can also maybe just factorize if rather than formula, so that could be easier. I have a k and k equals to 0. Two numbers timing to minus 10 would be minus 5 and plus 2, and adding up to minus 3. So from here, k would be equal to 5 and k would be equal to minus 2. So if I imagine or have a quick drawing for myself, that function k squared minus 3k minus 10, it is intersecting x at 5 and at minus 2. Also, the a for that, this 1, is positive. So this would be a function, quadratic function in this form, because a is positive. Now, we want k squared minus 3k minus 10 to be larger than 0. So where this function is larger than 0? If you look at this section of the function, and that section of the function is larger than 0, because that is where y is positive. But on the other hand, if we look at this section is negative, because these are where the y is, any point on those section has a y negative. So because this is larger than 0 and the positive side is important for us, basically the final answer would be k has to be larger than 5 And k could be larger than 5, or k could be less than -2. And it has to be larger or less, so not equal, because we have just larger. So we have to just larger or smaller. We shouldn't use or equal in here. So that would be the answer for this question. Question 10 says the diagram shows the circle with equation x squared plus y squared minus 8x minus 6y minus 20 equals 0. Find the center and radius of the circle, which is again a good question, and again it is related to basic algebra which you have started in GCSE. This is about completing the square, but we are going to complete the square for, if I just rearrange this to see how we're going to do this, I'm going to write x squared minus 8x plus y squared minus 6y, then minus 20 equals 0. So I'm going to complete the square for this and for this separately. And if you saw one of the previous questions that I did, when we are completing the square, this coefficient in here divided by 2, that is a b in which is the term that we will basically can write for have a completed square. So that divided by 2 is -4. In a way, that -4 is that this we can, for this 2 we can write x minus 4 squared. But if we do this x minus 4 squared, you will see that there's a plus 16 inside that. So to make that equal to this in here, I'm going to write minus 16. So the other way to look at it is that I could write x squared minus 8x plus 16 minus 16. This section is x minus 4 all squared. The second one, this minus 6 divided by 2 in here, that is minus 3. So I can write plus y minus 3 squared. Again, inside this is minus 3 times minus 3 is 9. So I need to add minus 9. So I have minus 20 equals 0. I take every number that I have in here to the right hand side. So this would be x minus 4 to the power of 2 plus y minus 3 to the power of 2 equals 25, and 20 goes to the other side, which would be 45. So this is the equation of a circle, which it has the center of 4 and 3. This equal to 0 gives x equal 4. This equal to 0 gives y equals 3. And this is r squared. So this is the center, and radius is square root of 45. So find the center and radius. And as you can see, somewhere around here, and this does look consistent with 4 and 3. So somewhere around here that we have 4 and we have 3 for the center. Next part of the question is the circle crosses the positive x-axis at point A. So which is, we have it in here, that is point A. Find the equation of the tangent to the circle at A. Find the equation of the tangent to the circle at A. So if you want to find the equation of tangent, if you look at here, we have that. So that is a tangent that we really, our aim is to find the equation of that tangent. One of the knowns that we have in here is this point A. Point A is a point that we can find what that point is by putting the y equals 0 in the equation of a circle. So I'm going to put a line in here. In equation of a circle, I'm going to put y equals 0 because that is where we have x intersection. So if I put that, I will have x minus 4 to the power of 2 squared y is equal to 0. Minus 3 times minus 3 squared would be 9. 9 goes to the other side, which would be 45 minus 9 would be 36. So x minus 4 would be equal to plus minus 6, which is the square root of 36. And from here, our x could be equal to plus 10, which is minus 4 comes to this side, minus 4 comes to that side, or x would be minus 2. And as you can see, again, we have the consistency. This is minus 2 and this is plus 10. So if we have plus 10, we could put that x equal 10 in as a considered as a point. So this would be 10 and 0. So this is a point that tangent will pass from point 10 and 0. What else we can find in here to basically what else we need to find out this to write the equation of the line? There are two methods that you can do in here. One method is the method that you will learn in later core 3 and core 4, which is implicit differentiation. If you do a differentiation of a circle, so that is what I'm not going to look at that now. But the other method that is expected for you to do in here is that from a center line to a point of tangent would create a 90-degree angle. And from previous section, we know that the center is 4 and 3. So whatever gradient of this line is, the gradient of that would be minus reciprocal, because those two lines are perpendicular to each other. So this is the point 10 and 0. So the other point, the center is 4 and 3. I can find the gradient of that. So gradient of the radius. So I can find this gradient in here. I'm just going to write that. That gradient would be delta y over delta x. That would be 3 minus 0 divided by 4 minus 10. And that would be 3 over minus 6, which would be minus 1 over 2. So gradient of that is minus 1 over 2. Gradient of a tangent, because it's perpendicular, would be minus reciprocal. So minus reciprocal of minus 1 over 2, this would be just 2. So gradient of a tangent is 2. So this gradient of this line is 2. So we have the gradient, and we have also, we know that's passing through 10 and 2. So I'm going to write in here gradient of tangent would be minus 1 over 2, minus reciprocal of that. If you do this, this is just 2. So I'm going to write the equation of the line C. So y would be equal to 2x plus c. Gradient is 2. Now we find out c by replacing this 10 and 0 inside that. So y would be equals to 2x, which is 20, plus c, which is c. We don't know. We're going to find out. So from here, c would be equal to minus 20. Now, if we place all of these things together, it adds up to equation y equals 2x minus 20, and that is the equation of the line C. And as you can see, this goes down, and somewhere in here around minus 20, that is where we have the y-intercept. So we can have a quick look at the consistency. Now, the next part of the question says that a second tangent to the circle is parallel to the tangent at A. So we have the tangent at A, we have a second tangent which is parallel to that. So could be somewhere around here. Find the equation of this second tangent. How we can find out the equation of the second tangent, which is in this side, parallel to a second tangent to the circle is parallel to the tangent at A. So parallel to the tangent at A, which is in the other side. So if you look at this, it would be similar. If we continue this in here, we will have an intersection that we are doing a tangent on that side. If I call this as a point D, line D, and we see how we can find the equation for that. For that line D, first of all, we know that that line D is parallel to the tangent at C. So the gradient of that line would be, gradient of D would be equal to the same as C, which is equal to 2. Now, the other point that we want to look at in here is we need a point from that line to be able to write the equation of the line, and this could be the point. So we need to find out what is this x and y of that point. The simplest idea to do this, because we can do it in different ways. One way is to find out, to consider this x and y and basically do some simultaneous equations that considering that that is on the circle and that is on the line of this radius. So if you like, we find the equation for this radius, equation of line, and we intersect it with the circle, and we will find this point and that point. So that is using a simultaneous equation to find that x and y. A different idea, which could be much more easier to look, is that this point is same as if we move to the same direction as and the same size, we will get basically to the other point in the other side. So from point A to point O, so if I just put point center, if I just show this by C, point C, which is center, from point A to the C, consider that this is 10 and 0, and that is 4 and 3, we are moving 6 to the left and 3 upwards. So we are moving 6 to the left and 3 upwards. Because this length and that length are also same, the radius are the same and in the same direction, from center to the point in this side, we have to do the same thing. We can do the same thing. So from 4 and 3, if we move 6 to the left, we will get -2, because 4 minus 6 is -2. And if we get 3 up, we will get 0.6. So this point basically is -2 and 6. The other way to look at it is that the center is average between this point and this point, because that is in the middle of this point and this point. So x of this center is average of x between that and here, and y of this center is y of that plus y of this divided by 2. So basically we are finding x and y that with A, when they average, they give us 4 and 3, which basically are -2 and 6, because -2 plus 10 is 8 divided by 2 is 4. This 6 plus 0 is 6 divided by 2 is 3. So equation of line would be again in the form of y equals 2x plus c, because gradient is 2, and we need to find c by putting considering that -2 and 6 on the line in here. So that would be y which is y is basically equals to 6. So I'm just going to put the values in here. So I'm just going to put the values in. So this would be 6 equals 2 times x, which is -4 plus c. So c would be equals to 10. So the final equation of the line of D would be y equals 2x plus 10. And as you can see, this point in here, this y intersect, this is very consistent to considering that that would be around value of 10. Okay, next part of the question is section 4. Another circle has center at origin and radius r. This circle lies wholly inside the first circle. Find the set of possible values of r. So what we are saying in here is that we come back in here, we have a point, okay, we could have a circles in here that could go around, but we want to find out what would be the maximum of the radius of those circles, that if the circles would stay still inside that larger circle. So if I go to a next page and I just draw this one more time, just to make this clear what's happening. So we have this circle in here. We are going to have other circles that are origin in here, could be here, but we want to see what is the maximum radius that those circles, those yellow circles, would still remain inside that red circle. So first of all, we know that the center in here is 3 and 4. I think I might have been wrong. I think it might be 4 and 3. If I just have a quick check. So the center is 4 and 3, yes. So if you go back to here and we say this center is 4 and 3. The distance that we want to find, the maximum radius, could be this section in here. So the maximum radius would be this distance. How we can find out that distance? That distance equals a total radius of the original larger circle minus this distance, which would give us that this distance in here, which is our objective. So this is really what we are looking for, to find out this d in here, that distance. The original radius of the circle, as you can see in here, it is square root of 45. So if we go back to the other side, this is square root of 45. This distance in here, it is Pythagoras between 0 and 0 and 4 and 3, which is basically would be 3 squared, 4 squared, which is 16, plus 9, which is 25, square root of 25. This would be 5. So the distance that we are looking there is equal to square root of 45 minus 5. And if we simplify the square root of 45, that is square root of 9 times square root of 5 minus 5. This would be 3 square root of 5 minus 5. So that is the maximum radius that these yellow circles could have for those circles to be inside the circle or exactly on the circle. Okay, if we go to the next question, which is the last question for this exam paper, the curve y equals 4x squared plus a over x plus 5 has a stationary point. Find the value of the positive constant a given that the y coordinates of the stationary point is 32. So first of all, again, this is quadratic. So stationary point is somewhere a point on a curve or on a functions that could be either minimum or they could be either they could be maximum. And how we find the stationary points? We could stationary points are the points that when they are minimum maximum, the tangent on that point on the for the curve is 0. The gradient of the tangent to the curve in those points is 0. So the gradient in here is 0. A gradient of that equals 0. So in these points, the gradient is equal to 0. And we know that the definition of the gradient basically is differentiation. So if we differentiate this function in here, so this one in here, and if we equate the differentiation to 0, that is where we find the stationary points. So if I differentiate this, this is basically 4x squared. This would be 8x. This one is ax to power of minus 1 because a over x. So that would be minus a x to power of minus 2, just doing a differentiation. So to find out a stationary point, what we need to do is to equate that to 0. That is where we have the stationary points. So I put this as a quadratic in this figure, but just to show the concept of stationary points. But stationary points could be in a form of, the functions could be in a form of this. So we could have one stationary points in here. So in different forms. So stationary points at any time is when we have the gradient equals to 0. So in this equation, the x that we find, it would be the x that would make that would give us the stationary point. But if we then replace that x back into here, then we will find the y coordinate of that stationary point. So because we already know the y coordinate of stationary point, we know that 32 also equals 4x squared plus a over x plus 5. So this is, if you like, y of stationary point. Just imagine that we solve this, we find x, we put the x in here, and then we find 32, but 32 is already been given to us. So in a way, we need to solve these two equations simultaneously to find out what is a, because that a is the a that would give us a stationary point, which is this. That stationary point will have the y coordinates of 32, which is this second equation. So we need to satisfy two conditions. So each one of these equations, they satisfy one condition. So if we solve them simultaneously, we will find the value for a. So to solve this simultaneously, I'm just trying to simplify, see if we can how we can simplify this to be able to solve it easier. So for this one, I can write 8x equals a over x squared, or I can say 8x cubed equals a from the first equation. From the second equation, if I if I replace this that I have found for a into the second equation. So if I replace that, which is substitution in a way. So substituting that, it is 32 equals 4x squared plus, for a, I'm going to write 8x cubed over x plus 5. 8x cubed over x would be 8x squared. So this would be 32 equals 8x squared plus 5. Take the 5 to the other side. So this would be 8x squared equals 27. X squared would be 27 over 8. So I'm going to have a quick check in here. So if x squared equals 27 over 8, then over a would be 8 times x cubed. So how we can find out x cubed? So what I can do in here, just to again look at a bit of algebraic work, and that is really the main objective from core 1. If I power both sides in here to power of 3 over 2, so this would be 27 over 8 to power of 3 over 2, and that would be x squared to power of 3 over 2. So we're powering both sides to 3 over 2. So if we do that, in the left-hand side, we will have x to power of cubed, to power of 3, which is x cubed, equals then I'm going to put in here, instead of 27 over 8, I'm going to write 3 over 2 to power of 3, because that is 27 over 8, and all of that to power of 3 over 2. So that would be 3 over 2 to power of 9 over 2. Now, looking at this, now comparing to this, we know that a equals 8 times x to the power of 3. Okay, so I'm just going to write in here, therefore a would be 8 times 3 over 2 to the power of 9 over 2. I know that basically 8 itself is a 2 to the power of 3. I can basically put all of these together. So that would be 2 to the power of 3 times 3 to the power of 9 over 2 divided by 2 to the power of 9 over 2. I'm just separating that bracket there. Now 3 minus 9 over 2. 9 over 2 is 4.5. So this would be 3 to the power of 9 over 2 divided by 2 to the power of 3 over 2. So if we simplify further, I think we can, the top part, we can write it 3 to the power of 3 times 3 to the power of 3 over 2. But generally, I think we should be able to leave it in that form. Considering that we have, we don't have, we could have had a bit of rounder number in here. I am going to have a quick check in here. So y dash equals 8x minus a x to the power of minus 2 plus 5 plus 0, that is fine. Then 32 equals 4x squared plus a over x plus 5. So from here, 8x equals a over x squared. So 8x squared x cubed equals a. So we replaced a with 8x cubed, which gives us 8x. Okay, so I see where the problem now is. So yes, there's a quick one that I'm going to correct quickly in here. 8x squared plus 4x squared, this should be 12. So this should be 12 in here. Now, so the over 8 in here is 12. So this would be again 12 in here. So when now I'm just going to quickly do this section again, just to simplify and get the last answer a bit simpler. I think it is always good to have a check when you don't get a right rounder number. So if I do that in here, so that would be x cubed equals 27 over 12 to the power of 3 over 2. Now my a would be equals to 8 is equals to, from here, 8 times x cubed. So that would be 8 times x cubed would be 8 times 27 over 12 to the power of 3 over 2. But we know that 8 itself equals 4 to the power of 3 over 2. Because 4 itself is 2 to the power of 2, to the power of 3 over 2 would be 2 to the power of 3, which is 8. So I can, for 8, I can write 4 to the power of 3 over 2. So this would be equal to 27. If I simplify this in here, so this would be equal to 4 times 27 divided by 12, all of that to the power of 3 over 2. Basically, that 4 goes inside the bracket to the power of 3 over 2. Now, there's some simplification here, that 4 and 12, that simplifies to 3. 27 over 3 is 9. So this would be equal to 9 to the power of 3 over 2. And this would be 3 to the power of 3. And the final answer is 27. So our value for a would be equal to 27. So do have a check if your final answer looks not simplified. So it's not simplifying, do have a check back. So as you can see, this is the end of this paper. And as you saw, we had a lot of use of quadratic equations, quadratic solutions, inequalities, sketching. and a lot of algebra in here. So this is an important step for core 2, core 3, and core 4 in A-level maths. I hope this video has been useful, and you can subscribe to our YouTube channel for updates.